Today we will discuss adjoint of a matrix. The adjoint of a matrix A is defined as the transpose of the cofactor matrix of A. It is usually denoted by adjoint ADJ. For example, A is equal to 1, 3, 4, 5. Find adjoint of A. Before discussing the adjoint of A, we are going to first discuss what is the cofactor of a determinant. Here A is equal to 1, 3, 4, 5. The elements we represented by A11, A12 first row second element, A21 second row first element, A22 second row second element. For finding the cofactor of the element 1, that is A11, we denoted by C11. Cofactor of the element first denoted by C11. C11 is equal to minus 1. Always you have to write minus 1 raised to 1 plus 1 and suppressing the element containing 1, the row 1, 3 and 1, 5. The remaining subdeterminant is determinant 5, that is equal to minus 1 the whole squared into 5, that is equal to 1 into 5, that is equal to 5. Similarly, C12 is equal to minus 1 raised to 1 plus 2. We are suppressing the elements, the row and the column, that is 1, 3 and 3, 5. The remaining subdeterminant is 4, that is equal to determinant 4. The value of the determinant 4 is the 4 itself, because 1 by 1 matrix, the determinant is the same value, that is minus 1 the whole cube, 1 plus 2, 1 plus 2 the whole cube into 4, that is equal to minus 1 the whole cube is minus 1 into 4 is equal to minus 4. Similarly, you can find out C21 and C22. Then we can write cofactor matrix of A, that is 5, minus 4, minus 3 and 1. Then we are going to find out adjoint of A. Adjoint of A is equal to transpose of the cofactor matrix A. You know what is transpose? That is interchanging rows and columns of the matrix A. That is equal to 5 minus 3 in the first row and minus 4, 1 in the second row. Find the adjoint of the following matrix. Matrix 3, 5, 1, 4, 3, 2, 1, 2, minus 3. So, let A is equal to 3, 5, 1, 4, 3, 2 and 1, 2, minus 3. First of all, you have to find out determinant of A. Determinant of A is equal to 3, 5, 1, 4, 3, 2 and 1, 2, minus 3. Then C11. So the cofactor of the first element 3 is equal to C11, that is minus 1 raised to 1 plus 1. We are suppressing the element containing row and column, that is 3, 5, 1 and 3, 4, 1. The remaining subdeterminant is 3, 2, 2 minus 3. That's equal to minus 1 the whole squared into 3 into minus 3 minus 2 into 2. That's equal to 1 into minus 9 minus 4. That is equal to minus 30. Then C12. The cofactor of this element, we are supplying is minus 1 raised to 1 plus 2, and we are suppressing this column and this row. The remaining subdeterminant is 4, 2, 1 minus 3. Expanding, we get minus 1 the whole cube into 4 into minus 3 minus 1 into 2. So the answer is 14. Similarly, you can find out C13 and C23, etc., etc. And finally, we can write the cofactor matrix of A is equal to minus 13, 14, 5, 17, 10, minus 1, minus 20, minus 2 and minus 1. Then already we discussed adjoint is equal to transpose of the cofactor matrix, that is equal to interchange. So first row becomes first column and second row becomes second column and third row becomes third column. Now we are going to discuss another concept, inverse or reciprocal of a matrix. Inverse means let A be a square matrix if there exists a matrix B such that A into B, which should be equal to B into A, that should be equal to I. I means unit matrix. Then A is called the inverse of B and B is called the inverse of A. It is denoted by A raised to minus 1 or A inverse. For mathematical purpose, we can be found out by this, by the formula A inverse is equal to adjoint of A ordered by determinant of A. So before doing the inverse, first of all we have to find out determinant A. So if determinant A is equal to 0, we know that adjoint A is a matrix and divided by 0 is not defined. So we can say that inverse does not exist. So for example, find the inverse of the following matrix. A is equal to 1, 3, 4, 5. First of all, we have to find out determinant of A. That's equal to 1 into 5 minus 4 into 3. That's equal to 5 minus 12. That's equal to minus 8. So determinant A is equal to minus 7 exists. Therefore, A inverse exists. Then we have to find out adjoint of A is equal to 5 minus 3 minus 4, 1. Then A inverse is equal to adjoint A by determinant of A. That is A inverse is equal to 1 by, we are dividing whole divided by determinant A. Instead of that, we can write 1 by determinant of A. That is 1 by minus 7. Matrix 5 minus 3 minus 4, 1. We have to remember adjoint and inverse are matrices. Then we are going to discuss a solution of equations using determinants and matrices. Solution of equations using determinants, we called it another name by Cramer's rule. For example, what is Cramer's rule? How to solve this by Cramer's rule? For example, solve the equation by Cramer's rule or determinants. Both are same. So first equation is 2x plus 3y is equal to 7, 5x plus 2y is equal to 12. For that, we are going to take, let D is equal to base matrix 2, 3 and 5 and 2. We can evaluate 2 into 2 minus 5 into 3. That is equal to 4 minus 15. That is equal to minus 11. Now we are going to find out another determinant. D1 is equal to, how to find out D1? So instead of the coefficient 2 and 5, we are replacing it by 7 and 12. So 7 and 12 and 3 and 2 is same. Again, we are going to evaluate 7 into 2 minus 12 into 3. That is equal to 14 minus 36 minus 22. Therefore, we can find out the value of x. X is equal to d1 by d. That is equal to minus 22 by minus 11. So answer is equal to 2. Similarly, we can find out d2. We are going to find out y. For that purpose, the coefficient of y we are going to replace by the constants. So that is 2, 5. Then the constants are 3 and 2. We are replacing it by 7 and 12. So evaluating, we get 2 into 12 minus 5 into 7. That is equal to 24 minus 35. That is equal to minus 1. Minus 11. Therefore, y is equal to d2 by d. That is equal to minus 11 by minus 11. So both are negative. The answer is equal to 1. What happens if d is equal to 0? If base matrix, the determinant of the base matrix is 0, then we cannot apply Cramer's rule for that problem. Another example we are going to discuss is a case study, commodity, variety and ABC, and varieties are 1, 2, 3, the commodities are ABC. Find the weights assigned to 3 weights using Cramer's rule. That means in this case we take it as x, y, z be the weights, then solved by the Cramer's rule. Another example we are going to discuss is 2x plus y plus z is equal to 1 and x minus y plus 2z is equal to 1 and 3x plus 2y minus z is equal to 4. In the last problem that only two variables are there, x and y. Here three variables x, y and z. So in this case D is equal to base matrix is 2, the coefficient of y is 1, nothing is specified, that is 1 into y is 1 or 1 into z, that is equal to 2, 1, 1, then 1, minus 1, 2, 3, 2 and minus 1. So evaluating 2 into minus 1 into minus 1 minus 2 into 2 and minus 1 into 1 into minus 1 minus 3 into 2, then plus 1 into 1 into 2 minus 3 into minus 1. Evaluating, we get answer is equal to 0. Already we discussed if D is equal to 0, we cannot find out the solution by the Cramer's rule. So in this case, answer we can't find out the solution. If D is equal to 0, then solution is obtained by replacing the coefficient of x by the constant term. That first part we are changing and 1 minus 1 4 is we replace by the constants and evaluating, and x is found out by x is equal to d1 by dt. Similarly, d2 is equal to, we are replacing the coefficient of y by the constant term and evaluating, we get y is equal to d2 by d. Similarly, for z, we are replacing the constant with the constant. Then we have to find out, evaluate d3 and z is equal to d3 by d. Then solution of equation using matrices. So in this case, first of all, we have to write the equations in the form Ax is equal to B, where A is the coefficient matrix and X is the column matrix of variables and B is the column matrix of constants. Then we have to find out the adjoint of the matrix is equal to transpose of the cofactor matrix. Then inverse, you have to find out the inverse of the matrix, and finally we can find out the solution by X is equal to A inverse B. X means X, Y, Z, A inverse B is equal to another a column matrix, then equating X is equal to first element, Y is equal to second element and Z is equal to third element. For example, we can do a problem 2x plus 3y is equal to 12 and 5x minus 4y is equal to 7. So it can be written in the form Ax is equal to B. So here are only two variables. So we are considering a 2 by 2 matrix. So in this case, if you are writing Ax is equal to B, where A is equal to 2, 3, 5 minus 4 and X is equal to the variables are xy, xy and B is equal to the constant 12, 1, 7. So if you are multiplying 2 into X plus 3 into Y, equating we get is equal to 12 and 5x minus 4y is equal to 7. So first of all we have to evaluate the determinant of the matrix A, determinant of 2, 3, 5 minus 1. So 2 into minus 4 minus 3 into 5, so answer is equal to minus 23. So here determinant A is not equal to 0, so A inverse exists. So we can find out A inverse is equal to adjoint A by determinant of A. So finding adjoint of A, we have to find out the cofactor, that is cofactor matrix. For that purpose, we have to find the four cofactors C11, C12, C21 and C22. C11 you can find out, that is equal to minus 4. C12 we can find out minus 5, C21 minus 3 and C14 is equal to 2. Then cofactor matrix is equal to interchanging rows and columns, we get minus 4, minus 5, minus 3 and minus 2. So adjoint of A is equal to transfer to the cofactor matrix, that is equal to minus 4, minus 3 and minus 5, 2. Therefore A inverse is equal to 1 by determinant of A into adjoint of A. We are all divided by determinant A. Instead of that, we can say 1 by the determinant of A is minus 23 into minus 4, minus 3, minus 5, 2. Therefore, solution is equal to X is equal to A inverse into B. B is the constant. Therefore, X means xy and A inverse is equal to 1 by minus 23 into minus 4, minus 3, minus 5, 2 into B. So, if you are multiplying first row into first column, minus 1 by 23. 1 by minus 23 means minus 1 by 23 into minus 4 into 12 plus minus 3 into 7. First element, and minus 5 into 12 plus 2 into 7. So evaluating we get 1 by minus 23 into minus 69 by minus 46. We are separately divided by minus 23. We get minus 69 by minus 23. So answer is equal to 3 and minus 46 minus 23 answer is equal to 2. So x is equal to 3 and y is equal to 2. Solution of that equation is x is equal to 3 and y is equal to 2. Similarly, again we can do a problem in three variables x, y and z. You can see that 2x plus 4y minus z is equal to 9 and 3x plus y plus 2z is equal to 7 and x plus 3y minus 3z is equal to 4. It can be written in the form Ax is equal to B, where A is the base matrix, that is the coefficient. You can write 2, 4, minus 1, 3, 1, 2 and 1, 3, minus 3. And x is the variables are x, y and z. B the constants are 9, 7 and 4. First of all, we have to find out determinant of A. So evaluating we get determinant of A is equal to minus 14. So it is not equal to 0. So we can say that A inverse exists. A inverse exists means it has a unique solution. That is x and y and z has only one solution. Then solution is x is equal to A inverse B. If determinant A is equal to 0, there are two possibilities. Either it should have more than one solution or one solution does not exist. Then A inverse is equal to adjoint of a determinant A. Then x is equal to A inverse into B. Thank you for visiting this video.